Today's class, we will be discussing about pointers review. So this is one of the very important topic for data structures to understand stacks, queues, linked lists. Especially, we need to know about pointers, and these pointers are very important for linked lists. Without this, in linked list, it will be very difficult to write a program or to overcome with the linked list. So first we will go with the definition of pointers, then we will see how to declare a pointer, what are the different dynamic memory allocations of pointers, how to write programs using those dynamic memory allocations. Okay, so now when we go with the pointer, so the pointer, look here, the pointer is a variable which contains the address in a memory of another variable. That is, a pointer contains the address of another variable. It contains the address, address of another variable. And always you have to remember that whatever the address you have, this address will also always be represented using ampersand symbol in our C language. Okay, look here, we have a pointer to any variable type. It can be any variable type, that is any data type. You can use any data type. Type can be integer, it can be character, it can be float, it can be double, any primitive data types, whichever you use, any primitive data types can be used to store the address of variable using this pointer. Okay, the unary operator and gives the address of a variable. This is very important. And symbol gives the address of a variable. The indirection not dereference operator star gives the contents of an object to a object pointed by a pointer. So you have to note down the two important things. One is ampersand symbol, that is unary operator, and one is star, that is dereferencing operator. So whenever you use this symbol, this stores the address of a variable. Whenever you use this symbol, this stores the value of that variable whichever the pointer is pointing to. Okay, so these are the two important things we will be using, very important things we will be using in the pointers. So now this is what a definition of pointer. A pointer is a variable which contains the address of another variable. Very important things, we will be using ampersand symbol and star. Ampersand stores the address of a variable, star gives the value of that variable. So now we will see how to declare a pointer. Look here, if we have declaration, for example, int I star pi. Okay, so how to declare a pointer? This is what I will declare a variable int I. I told you it is a variable which contains the address of another variable. First, you have to declare a variable using any of the data type. Okay, int pi. Then you have to declare that variable as a pointer. To declare that variable as a pointer, we will be using star. Okay, so the syntax, whatever you have to declare a variable is, you have to use data type followed by star, followed by variable name. So this is how we declare a pointer. So for example, we have to declare using int star pi. So this is variable, and I can declare one more variable int I. Why? Because it contains, this is a pointer which stores the address of another variable. So I have to declare one more variable. This variable's address will be stored in the pointer variable. Okay, so now look here, there is a sentence over here. I is an integer variable and pi is a pointer to an integer. We can say pi is equals to ampersand of I. That is what declaration of a variable, pointer variable. This is how we declare a pointer variable. Look here, that is what pi is equals to and of I. That is, now I is one variable. The address of this variable is stored in pointer variable. Look here, pi now holds the address of a variable, address of I. This holds the address of I. So this is what we have given here. PI is equals to and I. To hold the address of one variable, always first you have to declare a pointer variable, and then you have to declare that variable whichever you need to store the address. Okay, and whenever you are declaring a pointer variable, it should always be having star pointer variable comma any of the variable. Now that pointer variable is equals to and I, that is, it contains the address of the variable. So look here, the and I returns the address of I and assigns its value to the PI. So PI is containing the address of I. Okay, so now, for example, PI is equals to and I have written. This is what? This is very, very important thing. You have to note down in pointers and I. That is nothing but, for example, somewhere I is stored in the memory and the I will be here and the value of that I, for example, the address of that I is 1001. Okay, so now this PI contains, it doesn't contain the value, it will contain the address of I, because and symbol is nothing but the address. So this you have to remember when you write ampersand symbol, it holds the address. Now for example, I is equals to 10. I have given 10. Now I have to declare value to the variable PI. How to do that? So you have to use star. As I told you, star is one which gives the value of a variable. Look here, ampersand gives the address and value will be given by the star. So to get the star, look here, I have to write star pi, or pi is equals to star I. That is what the value. So in both cases, the integer 10 is stored as a value of I. Look here, you need to, in order to access the value of a pointer, you have to use star and then you'll get the value of that pointer. To store the address, you have to use ampersand symbol. To get the value, you have to use star. Okay, so this is how the pointers variables look. So pointer is a variable which contains the address of another variable. To get the address, we use this ampersand symbol. To get the value, we use this star symbol. Okay, so based on this pointers, we have dynamic memory allocation. What is this dynamic memory allocation? Look here, dynamic memory allocation is the process of allocating a memory to a variable during runtime or execution time. This is very, very, I am allocating a memory to a variable. For example, here I allocate a memory to this variable during the runtime or during the execution time with the help of pointers. Okay, so that is known as dynamic memory allocation. Static memory allocation is a process of allocating memory to a variable during compilation time. When I'm running a program, I will put the memory, that is, I allocate the memory to a variable, that is known as dynamic memory time. After running the program, I'll compile the program to check, get compilation. So while compiling a program, I will allocate certain memory, that is known as static memory allocation. Especially we will be using this dynamic memory allocation. What is this dynamic memory management? This involves the use of pointers and 4 standard libraries, namely malloc, colloc, realloc, and free. This is what dynamically means. User is allocating memory. The computer is not allocating memory to a variable. User is explicitly allocating a memory to a particular variable. I am the user. I want certain memory to be allocated by myself. So that is known as dynamic memory allocation. That will be done by the user with the help of standard library functions malloc, colloc, realloc, and free. So this is very, very important. These are the library functions that is we will be using to allocate the memory dynamically. Okay, so first 3 are used to allocate the memory, whereas the last is used to free the memory. That is malloc, colloc, realloc. Malloc is used to allocate the memory, colloc is used to allocate the memory, realloc is used to reallocate. That is, when you allocate a memory with the help of malloc and colloc, you have, for example, I allocate 4 bytes of a memory using either malloc or colloc. I don't want 4 bytes. I need to reallocate it to 2 bytes, or I need to delete or increase the value of the memory. So I can use reallocation. And finally, once you are done with allocating, at the end, you have to free the memory, because if you do not free the memory using malloc and colloc, the memory will be wasted. Once you free the memory, that memory will be free and other variable can use that memory. So we need free also when we are writing the programs using dynamic memory allocation. Okay, the pointers are used to point the blocks of memory allocated dynamically. This is very important. Why do we use pointers in this allocation? Use it to point the block of memory allocated dynamically. We need to point. I'll go with the programs. We need to see in the programs. We'll come to know why do we use pointers. Okay, these functions are always declared in standard library.h header file. So dynamic memory allocation is process of allocating of a memory to a variable during the runtime, and especially in dynamic memory allocation we use calloc, malloc, realloc and free. And this is calloc, malloc and realloc are used to allocate the memory, and free is used to free the memory. That is, you need to deallocate the memory once it is allocated. That is, you have to free the memory to other variable which you are using. So now we will go with each and every allocations, that is each and every library functions separately. So now we will see malloc. What is this malloc? Look here, malloc is used to allocate a required single block of memory of specified size dynamically and return a pointer of type void. Always this malloc, calloc or whatever you take, they will always return a type void. That is, return type is will be void, nothing will be written. Okay, and this is, look here, it will allocate a single block of memory. That is the difference between malloc and calloc. Malloc will be allocating single block at a time. Look here, when this is a memory required for me, it will allocate, for example, I require some 20 bytes of memory. It will not allocate this as the separate blocks. All whole together it will allocate as a 20 bytes, and you have to use this 20 bytes separately. Okay, that is known as malloc. It allocates a single block of memory of a specified dynamically and return a point void. Okay, this entire block will be allocated using malloc. And general form of malloc is, look here, data type star pointer, because we will be using pointers in this dynamic memory allocation to allocate the memory. Okay, so we are using pointer. Star pointer is equal to data type star. Malloc is a keyword, required amount of memory, size of data type. Whatever the size of the data type, that is required amount of memory is into the size of whatever the data type you have taken, that you have to mention over here. So this is the very important syntax of malloc. Example, int star pointer, I have to declare a pointer. I will declare a pointer. Now look here, this data type I can either here itself I can write, or in a single line I can write separate line. Int star ptr equals to int star, what is the data type you have to declare? Int star malloc. I want 100 bytes of data, that is 100 bytes. Look here, the size of amount of memory 100 into size of integer. So whatever the data type you declare for pointer, that will be taken as here. And now what is, for example, I'll take integer as a 2 bytes. So now this is 2 into 100, that is 200 bytes of data is allocated for me to run a program using malloc. Okay, so this is what this thing malloc. So look here, int star pointer equals to data type star malloc 100 into size of int, that is 100 into the size of whatever the integer you are using, that it will take. If you use character, it will take character. If you use float, it will take float. Okay, so now we will go with the next example. Look here, I have declared it as a character star pointer ptr equals to character. So whatever the data type you use, you have to use write the same data type over here. Look here, the same data type is written over here. That is what a syntax. So character star malloc of 100 into whatever the amount of memory you want, required amount of memory into the size of this character. Size of character is 1 byte. So here totally 100 bytes of data is allocated. This is how we need to write the syntax for malloc. And always remember, this malloc is required. This is used to require a single block of memory. Single block it will take. That is, for example, of this 100 bytes is there, all 100 bytes are allocated in a single block. It won't be divided like this. It won't be divided. Everything will be in a single block. From there, whatever, how much amount of data you are requiring at a time, it will be given. Okay, now there is a simple example for this malloc. Look here, this is a simple example, and always whenever you're writing a program, you have to use stdlib.h, because this calloc, malloc, free and realloc are present in stdlib.h header file. Okay, now look here, int main, int ni ptr comma sum equals to 0. This is used to find out the sum of a number using a pointer. The number of elements, scanf percentage d and n. Now look here, this is the memory allocation which I am doing dynamically with the help of malloc. Int star int star malloc n star size of an integer. If pointer is equals to null, error, memory not allocated. For example, now I have declared it as a pointer. If pointer is null, you have to show the message that memory is not allocated, because when null is there, memory is not allocated. When null is there, that is nothing is there, you have to display that memory is not allocated. If it is not null, you have to see that certain amount of memory is allocated and you have to push the elements into the array. Okay, so now look here, enter the elements of an array for I equals to 0, I less than and I plus plus, because you people already know how to enter the elements of an array using the keyword. Even I have specified this in one of the two sessions previously, what you can go through those videos also. For I equals to 0, I less than and I plus plus, scanf percentage d. Now look here, since we are using a pointer, I am using ptr plus I. Because I am declaring a variable as a pointer, I have to use this ptr plus I. That is nothing but ptr plus I is nothing but it will store the, it is nothing but address. It will store the address, and into that address the variable will go and set. Okay, now sum plus is equals to star ptr plus I. See, look here, star ptr plus I, this is nothing but the value. As I told you in the previous, star is nothing but value, ampersand is nothing but address. If you don't write an ampersand, it will just take an address defaultly. Now here specifying the address, in the particular address it will go, and now sum equals to sum plus star ptr. In that particular address, whatever the value is there, that will be counted here. Okay, and now you can find out the sum. Finally, you have to print the sum, printf percentage d sum. And look here, after allocating this malloc, I have allocated n star size of integer, how much amount of data you want, how much amount of memory you want, you can allocate using this memory. And always see that this malloc always allocates only single block of data. In that it will be split the blocks. Then finally, now after allocating and after executing everything, displaying the answer, look here, I need to free the data, that is free ptr. I need to free the variable so that that variable or the memory whichever I am using, that will be used for the next variable whichever you want to declare. So this is known as malloc. Now we will go with one more important header, that is kelloc. Okay, kelloc is used to allocate memory in terms of contiguous multiple blocks of specified size. Look here, malloc allocates a single block of memory, but whereas it allocates multiple block of memory, each of same size. That is the difference between malloc and kelloc. Whenever you take malloc, malloc will allocate a single block. But when you take a kelloc will allocate a contiguous block. How much amount of memory, whatever you want of same size. For example, this entire thing is of 50 bytes. You want to divide it into 2 bytes, 2 bytes, 2 bytes, 2 bytes. Like this, it will divide into contiguously one after the other. It will take. Here, when you have a continuous single allocation of memory, from here only you have to push the data, and somewhere it will keep on storing in the memory. But here when you take kelloc contiguous memory allocation, you can take this byte as a data, or even this byte as a data, or somewhere some little byte as a data. Like this, you can in middle you can pick wherever the space is there, wherever the space is free, the data will go and sit in that space. Okay, free space is there, it will go and sit in that space. But it is not possible in malloc because entire thing is a single block of memory. It is a contiguous block of same size. Wherever the data is free, the memory is allocated to the variable that where that data is there, wherever the free memory is there, that will be allocated to the variable. That is known as kelloc. There is a main difference between kelloc and malloc. General format of memory allocation using kelloc is, look here, this is also same thing like our malloc, only the thing is this will change. Data type star pointer equals to data type star kelloc, required amount of memory for element comma size of data. This is required amount of memory for the element comma size of data. Okay, but there it was like, it was required amount of memory into size of data type. Here there won't be into, that will be comma over here, that's all. There it was into because entire single block will be allocated, but here it is comma because it is multiple blocks are allocated, so we put comma over here. Okay, so what is the example? Look here, int star pointer, int star kelloc of 5 comma size of integer. This is an example. So 5 amount of, that is 5 different memory elements of size of integer is allocated. That is 5, 5, 1, 2, 3, 4, 5 of integer. That is of 2 bytes, 2 bytes, 2 bytes, 2 bytes, 2 bytes. Like this it will allocate. But in malloc it won't be like that. Continuously it will multiply 5 twos are, that is 5 twos are 10. Entire thing will be 10 bytes in malloc. But in kelloc it is not like that. It will be 2 bytes of 5 blocks will be allocated. This is what kelloc. Okay, some example for kelloc is given here. as include stdlib.h. You people already know. I told you whenever you're using Kellogg and Malloc, you have to use stdlib.h. PTR and sum equals to 0. This is the declaration. Enter the number of elements, and this is what the Kellogg syntax. Allocation int star Kellogg n comma size of int n. So PTR equals to null. As I told you, if nothing is there, memory is not allocated. If something is there, you have to show that memory is allocated. Something is there, you see to that you are allocating certain amount of data into that memory. Enter the number of elements into an array for I equals to 0, I less than. Same thing, only the syntax and the program, whichever I had written, same program is written over here, but only the thing is Kellogg is written instead of Malloc. Okay, here sum plus equals to star PTR. It will take the value from the PTR and it will give you the sum. Finally, you will display the sum. And very important thing, you have to free the memory whenever you are finally done. This is what free of PTR will free the data. Then return 0 because I'm writing int as a name. So this is what a Kellogg data type. Now we go to real. That is, I have allocated certain amount of memory using either Malloc or Kellogg. I need to either increase or decrease the size of data. This is mainly used to either increase or decrease the size of data. Size of memory you have already allocated. So that is known as reallocation of already allocated data. If the previous allocated memory is insufficient, realloc function can be used either for increasing the size, it can be used for decreasing the size. That is known as realloc. Now look the general format of Kellogg. So this is the general format of Kellogg. That is general format using allocating. I will allocate using the data either as Kellogg or Malloc. Now I have to deallocate. That is reallocate. Look here, data type star pointer, data type star. Reallocate is the data type. Sorry, it's a keyword pointer comma new size of data type. This is very important. New size, that is whatever the new size you are going to use, that you have to declare here. Look here, there is a simple example PTR. P equals to int star reallocate. P is the already previous existing pointer P comma 200 into size of integer. I am allocating new size. New size is 200 for me. 200 into the size, whatever the size is. For example, it is 2 bytes. So 400 extra bytes I am adding into the data. That is known as reallocation. Already I created, for example, I have already used certain 100 amount of data. I want to increase the size of data. I can use this reallocation. Increase the size or decrease the size. So example for realloc is given over here. But whenever you are using a realloc function, first you have to use either Malloc or Kellogg. Then only you have to use realloc because you have to assign or allocate the memory first. Then you have to reallocate the memory. So look here, PTR n1 comma n2 enter the size of an array. Now I have allocated the memory using Malloc. Malloc n star size of an integer. I am allocating memory using Malloc, and now for that I need to reallocate the memory. Now look here, these are the same whichever we have done in the previous example. Now reallocate of pointer comma n2. That is, I am reallocating the value whichever I am using for n1. Now I am reallocating the value and I'm changing the memory size using reallocation. Then finally, I'll print the value of pointer, whichever we are storing in the array. And then finally, actually there is no free over here. You have to write free of PTR. PTR you should write here and then return the pointer. But whenever you are using the reallocation function, first you have to use Malloc or Kellogg. Then you have to use reallocate. So this is what Malloc, Kellogg, reallocate function, and last we will go with very important free. As I told you in the last three important functions, this is very important function which we will be using with all, either it is Kellogg, Malloc or reallocate. Free. This function is used to free the dynamically allocated memory from Kellogg or Malloc or reallocate. General format is free of pointer. Okay, so you have to free the pointer whenever you are allocated using the memory. So this is what the dynamic memory allocation topic with the help of pointers. So thank you.